So here we want to find the length of arc FG. So FG is the distance from here around to there. Okay, so we're finding an arc length, so we need to use the proportion arc length over circumference, which is 2 pi r, equals arc measure, so the degree of that arc, divided by 360.
Wait.
So in order to find arc length, I need to know two things: the radius of my circle and the arc for my angle. So first, let's find the radius, the distance from here to here. Okay. One thing that we need to know is if you have a triangle that has a diameter as one of its sides, then that angle is going to be a right angle. Okay, so we have an intercepted arc down here of 180 degrees. So that's an inscribed angle, which happens to be 90 degrees. So both of these triangles are 90-degree triangles, which means I can use Pythagoras to figure out what the hypotenuse is. And in this case, I'm calling it D because the hypotenuse is the diameter of this circle. So 3 squared plus 4 squared is 25, and the square root of 25 is 5. So the whole entire diameter is 5, which means I have a radius of 2.5. Check. So now I can erase that here. I know that the radius is 2.5, so I will multiply 2.5 right here. So now I have to figure out what the arc measure is. What is the degree of that arc? Okay, which is a little bit more involved. So let me erase all of this stuff that I've done so far. Now there's two ways that we can find the measure of an arc. One way is if we knew the central angle. Okay, because the central angle is equal to the arc. Those have the same measure. Okay, that's one way. The other way would be if we knew an inscribed angle, because there's also a relationship between the inscribed angle and this arc. And that is that the arc is 2 times the angle. Now that is probably going to be the way to go, because I can use this triangle because it's part of a right triangle, rather than try and figure out what this yellow angle is here, which is not part of anything interesting. So let's figure out what this angle is down here using our trig ratios. So let me redraw this triangle here. This is the bottom triangle with a side of 3 and a side of 4 and a hypotenuse of 5. Now I'm going to figure out what this angle is. Since these triangles are congruent, I can do one of them. Now I have all 3 sides, so I can use whatever trig ratio I want. So I'm going to choose to use tangent. You can use sine and cosine as long as you use the right ratio. So tangent is the opposite side length compared to the adjacent side. And we always find an angle in trig by taking the inverse. So if I do inverse tan of 3 divided by 4, I find that that's an angle of 36.9 degrees. Erase that. This angle is 36.9 degrees. Just 1 decimal is okay for me. 36.9, remember that. So coming back over here, this is now 36.9 degrees. This is also 36.9 degrees. So this whole angle, if I add these two up, becomes 73.8. So that is the measure of my inscribed angle, which means my arc is 2 times that, 147.6 degrees is the measure of my arc all the way around there. 147.6. Good, that comes over here now. After I erase this, I put in 147.6, the measure of my arc. in degrees. Now I cross multiply, and I can finally solve for the arc length from F to G, now that I know all of my information. So when the calculator, listen, I do 147.6 times 2 times 2.5 times pi, and I divide all that by 360, and I get an arc length of 6.4403, and my units are undisclosed, so 6.4403 units is the length of my arc. So this is a really hard arc length problem. We had to find the radius, and we had to find the measure of that arc. One used trig, one used the Pythagorean theorem.